So welcome to the lecture on programming in Python, data analysis and deep learning. This is a new lecture that we are actually giving for the first time. So you will experience something new here. What we did is actually we structured the lectures a little bit. In the past, we had two lectures, one which was called Introduction to Computer Science, and the other one was Programming in Java. And we restructured the lecture Introduction to Computer Science to also include programming. So because of doing this, the lecture Programming in Java became redundant, so we didn't need it anymore. So we replaced it by this lecture. Is there anybody here who wanted to come to the lecture Programming in Java? Okay. Huh?
It was in our module plan.
Yeah.
To go there.
Yeah.
I think it doesn't matter if it's Java or Python.
Yeah. So the lecture Programming in Java is being replaced officially by the lecture Human-Computer Interaction 1, which will be in the summer semester. But you can also replace it by this lecture. So you can choose between both. The only difference is that in this lecture, I assume that you already have programmed in some language. If you have never programmed in any language, you can still attend the lecture. It will be a bit steeper for you. So who has never programmed in any language? Oh, okay, there's a lot of people. Who of you has attended the lecture Introduction to Computer Science? Einführung in die Informatik für höhere andere Fachrichtungen. Okay. Who's going to attend it this year? So you're not planning to attend the... Okay, so probably those people who have never programmed before should attend instead the lecture Einführung in die Informatik für höhere andere Fachrichtungen. Yes. Ja. Wer sagt das? Was studieren Sie denn? Oh, yes. So, you're studying Wirtschaftsingenieurwesen and you have never programmed. But you're learning to, okay, but you stay here. Okay, for you it will be a bit steeper, that's fine. Because in the past I had Wirtschaftsingenieure in the Introduction to Computer Science, and I think you have some mathematical background and so on, so you can stay here. Are you also a Wirtschaftsingenieur or you're something else? Yeah? Physics, okay, you stay here. I'm starting from zero, don't worry. If you had some mathematics lectures, I think that's fine. Yeah. I think it's mostly, is there anybody who has never programmed and doesn't have a natural science or engineering background? Okay, yes. Okay, I think you will probably be fine. So you can consider whether you want to go to the Introduction to Computer Science for other majors. It's Introduction to Programming for people who have never programmed before and who are not like engineers or natural scientists and who don't have any math background and so on. This lecture, so in the past everything was together, which didn't make any sense because it was on a different challenging, mostly for Geisteswissenschaftler. It tended to, for some of them, they tended to need a little bit more time to learn programming, while the physicists and Wirtschaftsingenieure and so on, they were faster. So now we split this. And so, you can judge for yourself. If you think this is really going too fast and so on, you can go to the Einführung in die Informatik für höhere andere Fachrichtungen. But I think if you're a Wirtschaftsingenieur or a physicist or a mathematician or something, or a natural biologist or whatever, I think you will be much better in this lecture. Yeah, I think you're fine here, don't worry. Yeah. Okay, otherwise, if there are some questions about this new lecture and the relation to the programming in Java and so on, you can come to me later. So, what we will do in this lecture is I will teach you programming from zero, so don't worry, we start from scratch, in Python. But it will go faster than the other lecture, the Einführung in die Informatik für höhere andere Fachrichtungen. So it will be a bit faster. And then I will teach you how to use Python instead of something like MATLAB or so. Has anybody used MATLAB? Okay. I think it's okay if you're in university, but later you will have to pay a lot of money. And Python is much better. So I recommend you for most of the things where you would use MATLAB, probably to use Python. So I will teach you how to work with matrices in Python, and then we will do a bit of linear algebra in Python, and so on. Then we will I will teach you how to analyze data. So given you have a data set, either in the CSV file or whatever, MATLAB file or in a database, how to load that data into Python using pandas, and then how to analyze the data, how to plot data, how to run basic statistics, and so on. And then a big part of the lecture will be one specific point of data analysis, which is deep learning. So you will learn how to use neural networks and in particular deep learning to represent data and to analyze data. That's a quite new topic. I think there's no other course that I know of at the University of Bayreuth who teaches deep learning. Is there any other? Does anybody know of another course that teaches deep learning? Okay, so that's the newest data analysis technique where there's a big hype about, and it works very well for some data sets. And apparently a lot of companies are asking for people who know how to do it. The grading for this lecture is that we have mandatory exercises, which are, so there's exercise sheets provided by Arthur Fleig. So these exercise sheets are 15% of the grade, and you can submit in teams of 2 maximum. And then we have a final exam at the end of the semester, which is 85% of the grade. Okay. Are there any questions so far? Yes? Excuse me? No, that's in German. So if you don't speak German, you have to attend this course. You will learn similar stuff, just more and faster. Yes? Yes. So this course can be taken by students of informatics, bachelor and master, by master of computer science, mathematics, physics, Wirtschaftsingenieurwesen, and a lot of other fields that we will have a short round in a second to ask where people are coming from. But almost anybody, I think, can take this course. Are there any other questions? Okay, Arthur, do you want to say a few words about the exercises?
Yes. Okay. Hello, and welcome to the lecture, also from my side. So, as Professor Müller already said, there will be mandatory exercises starting today. So, during the day, at some point, I will upload the first exercise sheet on the e-learning course. So, you have to sign up on the corresponding e-learning course. Please do that. There's no password, just sign up, and there you will find all information. You have 1 week, and every week there will be a new exercise sheet. So next Tuesday you will have to submit the first exercise sheet to grade for us. There will be exercises today also, so we'll start at 12:30 is the first group, so there are 2 exercise groups. Group 1, and actually we didn't expect so many of you to be here, so there are currently 2 groups in room S112. Maybe it's too small and we will have to see if we can get bigger rooms or whatever. So group 1 is Tuesday from 12:30 to 14, and group 2 is also Tuesday from 14:15 to 15:45 in S112. It's in the same building on the 2nd floor. And in this week's exercise, yes?
I just have a question if the exercise sheets will be we cannot attend to the exercises because we have a lecture in our main subject that is parallel to the exercises.
Both exercises? Okay, who cannot attend both exercises? 7. Okay, can you attend Wednesday between 2 and 4? No. Then I don't know if we can find a solution. So, because the solutions will not be uploaded to e-learning, and you will have to get the solutions otherwise. I mean, we can try to switch sometimes, but then some other people cannot go to this lecture and so on and so forth. But we will have to see about the rooms anyway, because maybe the rooms that we currently have are too small and we might have to switch sometimes around to fit all of you. Or maybe instead of, because there was an intensive exercise on Wednesday planned, maybe we need to have 3 exercise groups. Maybe we need to discuss that. So we will have to see what we can do. We can try, but I cannot make any promises. Yes?
I wanted to just say, is it possible to attend only the first half of the exercise because of the other lecture we have? I think it would be possible to be there for an hour.
I mean, you don't have to attend the exercises at all. It's just for you where we discuss the exercises and either you or I present the solutions to these exercises. So you don't, I will not make a list of attendance. It's just for you to have some sort of solutions in order to study for the exam. So yes, you can attend for 1 hour and then. Today, in the exercises, it's going to be a short exercise, and it's only for those of you who need help in installing software. So we'll install a Python environment and install everything that you need to start working on the exercise. So if you need any help, then come to the exercises today or to my office. And if you don't, you can skip today's exercises. Okay? You will need Python 3, and there's this Anaconda distribution on anaconda.com that you can download, and it installs Jupyter Lab and all sorts of other things. Modules like NumPy, Pandas, Keras, and so on, and these are all included in Anaconda. So you will only need to install 1 big package. The installation takes about half an hour, depending on your hardware, and then you're set, right? So this I can help you with today. If you cannot attend this lecture but need help, please come to me this week, because otherwise you might not be able to start on the exercise. I think that's it from me.
Okay, thanks.
Thank you.
Cool. A few important points. We will use exclusively Python 3. Python 2 is outdated and you should not use it anymore. Python 2 is incompatible with Python 3. And we use it from the Anaconda distribution. You don't have to use Anaconda, but we recommend it because it's 1 big package that comes with all the libraries that you will need. Then I will do all my programming in Jupyter Lab. That's a web-based, it's a web-based environment. I hope we will. And this one. So you program directly in this web-based environment. We will provide you with a server where you can log in, and you can program on our server. You can also program on your own machine if you can install Anaconda. Probably it's a bit more convenient to do the work on your own machine, but if for some reasons you don't want to or you can't, you can work on our server. I think we'll put the link to the server in the e-learning. The server will be restarted every night at around 4 a.m. So don't do your exercises at 4 a.m. Because the server might restart. Okay, you don't have to do your programming in Jupyter Lab. It's just this web-based IDE which is convenient. The most important libraries that we will use later in the course is NumPy. NumPy gives you this MATLAB-like environment where you can work with matrices and so on. Then we will use Pandas, which gives you something like an Excel sheet, where every column can have a different data type. And you can, Pandas is Python for data science. And it gives you all this data science capabilities. And then for deep learning, we will use Keras with the TensorFlow backend. Don't worry about these now. These will only come later in the course. And in the beginning, we will start with vanilla Python. I want to get a quick overview of who is studying what. Who's a computer scientist in this room? Okay. Yeah, so the computer scientist can attend the lecture, but it's not correctly set up on Campus Online. So we will fix that so that it's visible also for computer scientists. In the meanwhile, maybe you can advertise it in computer science, right? Computer science or informatic. Everybody from computer science and informatic can take this lecture. Okay, then we have Wirtschaftsingenieur. Who's a Wirtschaftsingenieur? Oh, that's quite a few. Okay, who's a physicist? Oh, lots of physicists. Who's a mathematician? Who is something else? Okay, oh, that's a lot of else. Okay, maybe somebody can start with, can you start?
Yeah, we came from Medienwissenschaft and Medienpraxis.
Okay, who is Medienwissen? Oh, okay, that's quite a few. Okay, who is something else than that? Yes?
Medienwirtschaft, Medienkultur.
Okay, and who is still something else? Yes? Okay. Still something else? Yes? Okay. Something further? Okay. Good. So, who has programmed before in some language? Who has programmed before in Python? Oh, quite a few. Okay. So maybe the first few lectures will be a bit boring for those who already know Python. But I mean, you can use them as a repetition, or I mean, all the lectures will be video recorded. So you don't really have to come here if you already know Python, and you can just watch the lectures online at double speed or something, just to recap. Okay, so are there any other questions regarding the organization of this course? Okay, then I think, yes.
What's the e-learning called? Because you can find it.
You can find it. Arthur will put it. Yeah. Oh yes, that's the English name. Yeah. If you cannot find it, ask Arthur, I guess. Yeah.
Just search your name, and in your name, it's like courses coming according to your name. Just search your name.
Yeah. Yeah. Then you can find it. Okay. Yeah. Somebody searches for my name, you can probably find it. Okay. Then you're happy to advertise this course to other people who might be interested in data analysis and deep learning, who might not know about the course because it's new. And people can still start later. Hopefully not so much later, so they don't miss too many exercise sheets. Okay, let's start with Python. So this is the Jupyter Lab. This is, before there was a Jupyter Notebook or IPython Notebook, and this is the latest version of that. And you can program in these cells, and you can write some code, and you can also write text. And you can, so you can switch between Markdown, so that's text, structured text, and code. And for example, I think the most basic thing that you can do is you can use Python as a calculator. So if you want to use, calculate something like 3 plus 5. For those in the last row, can you still read this? Okay. So if you want to calculate something like 3 plus 5, Python does that for you, right? That's like the most basic thing. One of the most common errors I see in exams is that people calculate something, but they don't do anything with it, right? The problem is now you calculated 3 plus 5, but afterwards you cannot access that anymore. So most of the time you want to put that, you want to remember that, right? And to do that you can create a variable, maybe a variable called x, and then you can calculate 3 plus 5 and store that in the variable x. And now you don't get an output, but now you can ask for what's stored in that variable x. And so x basically now points to this number 8, and all these objects in Python, they have a data type, and you can ask for the data type with type. So we can ask for the data type of x, and Python tells it it's int. And int is short for integer, so it means that it's a whole number. So it cannot be like 3.2, it can only be 3 or 4. And then, because it's still stored in this variable x, we can also calculate something like x minus 2, and we can then store that in this variable x again. So what we do here is we calculate x minus 2, and we store the result in the variable x. And you can execute the code if you press Shift-Enter in IPython Notebook. And now x is 6, right? We just subtracted a 2 from x. We can also multiply integers. So we can say x is x times 5, for example. Now x is 30. And we can also divide. But we have to be a bit careful if we divide, because if we divide, the result might not be an integer, right? So if we, for example, if we would divide 30 by 7, then the result would not be a whole number, but it would be a fractional number. But if we want to have a whole number, we can divide x by 3, for example, and we can use this double slash to say this is floor division. And floor division means that it's the next whole number that's lower than the result. We probably want to assign that to x. And we can also put multiple lines of code in each of these cells. So if I just press enter, then I get a new line, and I can execute both lines of code at the same time. And now x is still an integer. If you want, so you can add comments to your code. If you add this hash symbol, and if you add a hash symbol, then everything starting from that hash symbol to the end of the line will be ignored by it will not be interpreted as Python code. So it's just for humans to read. So for example, here we can explain that this is actually floor division. Okay, I think that's mostly integers. We can add, subtract, multiply, and divide them. And are there any questions so far? Yes? No, it gives you a floating point number. So if you divide with normal division, Python always gives you a floating point number. I will explain that in a few minutes when I talk about floating point numbers. So of course these integers, these numbers have to be stored in the computer somehow, and they are stored as bits of ones and zeros, and we can check for that ones and zeros by asking for the binary representation. And the binary x is 10. You see here that x was 10, and the binary representation of 10 is 1010. So here this 0b only means that this is a binary representation, and so a representation that only contains ones and zeros, and 10 is 1010. So we have the number 10 in decimals, in decimal system, that corresponds to 1010. And this basically only means that it's 0 times 2 to the 0, which is 1, plus 1 times 2 to the 1, which is 2, plus 0 times 2 to the power of 2, plus 1 times 0 times 2 to the power of 3. So 2 to the power of 3 is 8. So this is 8 plus 2 to the power of 1 is 2. So this is 10, right? This is the binary representation of the number 10. This binary representation is very inconvenient for humans because you only have numbers 0 and 1. So we also have hex representation. And in the hex representation, the number 10 is represented by the letter A. I think if you don't know what hex is, you don't really have to. It's not important for this lecture. Okay, now the next question is, what happens if you divide with a normal division? You don't divide with the floor division. So this will give you a different data type, not an integer, but a float. So in this IPython notebook, you can also write text cells. And if you say that, what was x? X was 10. Okay, so if you divide x by 3, for example, this will not be a whole number, right? So if you say that y is x divided by 3, then the result is 3.3. And this obviously is not a whole number. So the type of y, it's now not integer, but it's float. And float means it's a floating point number, right? So there's something after the period. Otherwise, floating point numbers really behave mostly like ints, so you can add them. You can, for example, you can calculate something like y equals y plus 2. So you can add 2 to this, and you can also say y equals y times 4.1 or 4.2. So you can calculate with floating point numbers as you like, and the result will always be a floating point number. So the type of y, it's still float. So this is basically just calculating. And the good thing about floating point numbers is that you can represent both very large and very small numbers. And if you want to represent a very large number, like the number of meters from the Earth to the Moon or something, then it would be very inconvenient to write it in this normal decimal notation. And what we will usually, somebody can say, what do you use if you have very large or very small numbers? What kind of notation do you use? Some physicists, maybe. Yeah, there's this scientific notation, right? So you give it as an exponent. So you don't actually write 10 and or 1 with 5 zeros, but you write 1 times 10 to the 5. right? And this is much more convenient, especially if the number gets super large. Then you only have to write this part and this part. And this is, we call the Mantissa in German. And this we call the exponent. And this is how actually floating point numbers are not stored like this in the computer. Inside the computer, they're stored like this. So you separately store this part, the mantissa, and the exponent. And you can do that in Python. You can, for example, say that z is equal to 1e8. So that's how you say it. And this means 1 times 10 to the 8, right? So instead of writing 1 times 10 to the 8th power, you write 1e8. That's just a concise notation. Maybe we can look into z. Okay, and then if you look at the number, then this is a 1 with 8 zeros, right? And the nice thing about scientific notation is that it doesn't only work, this exponent doesn't have to be positive, it can also be negative, right? So if you want to have a number with a lot of zeros after the comma, then you can say this is 1 times 10 to the minus 4. So we can write 1e minus 4, and this will give us 0.0001. And this is just if you want to work with very large or very small numbers, use scientific notation for that. Okay, so are there any questions regarding scientific notation? You have to be a bit careful because your computer stores this part and the exponent, but the computer doesn't have unlimited memory for this, right? So if you have a very large exponent which does not fit into the memory for this number, then Python says, oh, this is too big for me. I don't have the memory to store this number, so I just say it's infinity. So if you say that you want to have a number 1 times e to the 10,000, then Python says, well, 1 to the 10,000, it's too big. So for me, it's just infinity. And infinity means, it says inf. So we can store that into a variable z. And but the type of z is still a float. It's just a float that has the value infinity, right? We also have negative infinity, so we can also look at the number 1 times e to the minus 10,000. Oh, this is actually 0. This is not what I intended. I intended minus 1 times e to the 10,000. This is minus infinity. And now the question is what happens if we say that b is equal to z plus a. The value of a z is infinity, and the value of a is minus infinity. So does anybody have an idea what z plus a is? 0, okay. Who votes for 0? Who votes for something else? Okay, well, why not 0? Does anybody have?
It's not possible, it's not defined.
Yeah, exactly. Minus infinity plus infinity is not defined. And not defined in Python means, does anybody know what not defined means? How do you represent not defined? Okay. So the Python word for that is not a number. I think mathematicians would say undefined, but computer scientists say not a number. It's something, but it's not a number. So that's the special values. NaN is not a number. And then if you have not a number times 3, it's still not a number, right? Okay, and the type of this variable b, where the value is not a number, it's still float, right? So float can be numbers represented in scientific notations, or they can be infinity, or they can be negative infinity, or they can be not a number. So we have different values for float. Then you have to be a bit careful with float. So for example, if you calculate 0 plus 1 plus 0.1 plus 0.2 should be, does anybody have an idea what this should be? Should be 0.3 probably, right? Let's check that. With this, we can test. We ask Python to calculate 0.1 plus 0.2 and check whether the result is 0.3. Does anybody have an idea what the result of this calculation would be? So the result could be true or false, right? So will Python say true or will it say false? Do you think 0.1 plus 0.2 is 0.3 or it's not 0.3? Maybe let's ask Python. Oops. So Python claims that 0.1 plus 0.2 is not 0.3. Does anybody have an idea why Python thinks so? Well, I think everybody in this room would think otherwise. Yes?
Maybe because you need to use commas and not points, maybe?
No, it's not a syntax error. Maybe we can approach the problem by calculating 0.1 plus 0.2 and the whole thing minus 0.3. Okay, so this should be 0, right? But it's not 0. It's 5 times 10 to the minus 17. So 0.1 plus 0.2 minus 0.3 is 5 times 10 to the minus 17. Yes. Anybody has an idea why this is the case? Yes?
Maybe because the computer works with binary numbers and routing is not exactly.
Yeah, that's exact. So before we calculated before up here we calculated 10 divided by 3. So if we work in decimal system, then 10 divided by 3 is 3.3333 and so on, right? And these 3's should continue forever. But the computer doesn't have infinite memory, so it has to cut off somewhere. Right? So it does not, so in decimal, we could not represent this number exactly. And in binary, we have the same problem with the number 0.1. That the number 0.1 contains a period somewhere. So it cannot be represented exactly in binary format. So 0.1 will be, I don't know what's a bit string. You can look it up maybe. But it's an infinite bit string. So it contains a period. So if we represent the number 0.1 inside the computer, it cannot represent it exactly. It can only represent it approximately. And that's a fundamental problem with floats, that most of the calculations, or often these calculations, are not exact, but they are only approximate, because you cut off at some accuracy after the comma, right? So your floats always round. So you should never use a test for equality when you're using float. Does anybody have an idea of what we can do instead of testing for equality? So if we want to test that 0.1 plus 0.2 is not exactly 0.3 if we calculate in floats. Instead, it's only approximately 0.3. Does anybody have an idea how we can test for approximately equal? Yes?
We can probably take the one that we just calculated and run it against some number like 5 times 10 to the minus 15.
Yeah.
It's smaller.
So let's do that. We define an epsilon. We define epsilon as, I don't know, maybe 1 times 10 to the minus 15. This is the accuracy that we want, right? And then what we do is we check whether 0.1 plus 0.2 minus 0.3, and now it can go both ways. It can be bigger or smaller, so than 0 is the result. So we take the absolute value of this, and then we check whether this is smaller than epsilon. Right. And now it's 2. So this means that the absolute value of 0.1 plus 0.2 minus 0.3 is, the absolute value of that is very, very small. So it's smaller than the accuracy that we want. So it's approximately 0. So when you calculate with floats, you should do something like this. Are there some questions regarding floats and float accuracy? Okay. Yeah?
Why do you need this absolute value?
Hmm?
Why do you need this absolute value? Why don't you just do that?
It might be that, I mean, if you don't take the absolute value here, actually I've seen that mistake a couple of times in exam, so I will explain it now. So if you say 0.1 plus 0.2, if you want to check whether this is approximately 5, right, and you don't take the absolute value, and you code something like this, then what will this give you, this line of code? Will it say true or false? Well, it will actually say true, right? Because 0.1 plus 0.2 are approximately 0.3, and minus 5, that is negative 4.7, and this is smaller than epsilon. Yeah, absolute value is Betrag, yeah. So you always have to take the absolute value, right? Because otherwise you, all these negative numbers will give you true otherwise. Okay, now we've looked at integers. Integers are whole numbers, and floats are, how do you say, fractional numbers, or Brüche, yeah? Or they have a comma, or they have a decimal point, and they have something after the decimal point. And then we also have Boolean numbers, not Boolean, Boolean is another data type. So this true that we saw here, this is actually also a value, right? Maybe we can assign that to a variable. Ans is this. So now the answer is true, but this true also has a data type, so we can look for the type of ans, and it's bool, right? And Boolean is another data type that can only be true or false. So the two possible values for Booleans are true or false. So maybe if here it was true, oops. Maybe if we correct this by taking the absolute value here, then the result will be false, and it's still a bool, right? So the two possible values for Booleans are true and false. So everything that I code here will be available on the e-learning. So the everything that was on the that I coded in the computer. Okay, so two booleans can take the value true or false, and of course we cannot add or subtract booleans, right? Boolean would be in German would be Wahrheitswerte, so it can be true or false, truth values. But we cannot add or subtract them, but we can do logical. We can use logical operators. So, for example, we can do something like this. 3 is bigger than 4, and 4 is bigger than 3. And this AND, what this AND means is that this will only give us the value true if both the left side is true and the right side is true, right? So this will give us the value false, because 3 is bigger than 4 is false, and 4 is bigger than 3 is true, but false and true will be false, right? Then there's also OR. And what OR does, it gives you the value true if either if the left side is true or the right side is true, or left and right side are true. So this will give you true because the right side is true. The left side is false, but the right side is true, so the OR gives you the overall value true. Then you can also test for equality. 4 is equal to 3. And if you test for equality, then you have to use this equal sign 2 times. 2 times equals sign. Can anybody say why you have to use the equal sign 2 times if you want to test for equality? In mathematics, you will only say equals, right? Yeah. Yeah. Exactly. So if you use the 1 equal sign, then you can say x is equal to 3, and this assigns the value 3 to the variable x. And if you want to say test that x is equal to 3, then you have to use the equal sign 2 times, just to disambiguate that you don't mean this variable assignment here. Then you can also test for not equal. 4 is not equal to 3, and then you can also do something like this. Not 2 is equal to 6. So what happens here is, this is one operator that compares 4 to 3. And so this tests for 4 is not equal to 3. And then you have this and this not, basically not 2 is equal to 6 is exactly the same thing as 2 is not equal to 6, right? So you can use this not operator to negate what's following that operator. And you can also check for the type of true. Type of true is of course a bool. And you can also use Boolean variables, this true and false directly. So for example, you can ask for true or false, and that gives you true overall. You will probably use these Boolean operators quite a bit later during programming. Are there some questions regarding Booleans? Okay. So you will get much more practice with this during the exercises if you program yourselves. This is actually the best way to to learn. Programming is a little bit like riding a bicycle. I mean, I can give you like 20 lectures about how to ride a bicycle, but unless you go out and start riding the bicycle, you will not learn much. So the exercises are really crucial for this entire lecture. Okay, then in addition, we also have complex numbers, which I find quite nice, especially for engineers and physicists, because if you don't have complex numbers in your programming language, it can be a mess. So we have complex numbers as a native data type. If you don't know what complex numbers are, don't worry, you will not use them. You will not need them. You only need complex numbers if you know what they are. Python follows the engineering notation, and the imaginary number is it's not I, but j. So you can define the number as 2 plus 3j. And this is 2 plus 3j, or 2 plus 3i for mathematicians. What do physicists use, I or j? I, okay. So you have to get used to j instead of I. And the type of A is now complex, so it's a complex number. I think that's it. You can do calculations with complex numbers. In order to do something interesting, we have to import some libraries, which in Python you do like this. For example, we want pi from, and then you type from math. So there's a library called math, which contains all the interesting mathematical functions. And you can say from math import pi. This is the number pi, right? And from CMath, CMath is math with complex numbers. Import exp. There's an exp function in math which does not work with complex numbers. So if you want to work with complex numbers, you have to import it from CMath. And then, for example, you can calculate e to the j pi. E to the j pi should be, anybody can calculate this? Yeah, -1, exactly. Let's do that. B is exp of 1 times j times pi. Let's look at B. And here again, you see that in Python, it's not -1. It's -1 times 1.2 times e to the -16j. So it's very close to -1, but it's not a real number. It's a complex number. It has a very small inaccuracy into the complex domain. Okay, I think that's it for complex numbers. I think you only need them if you're an engineer or mathematician or physicist. Otherwise, don't worry about complex numbers until you need them. I think that are the most important numeric data types. Then there's also, you can also represent text in Python. And text is called strings. For example, you can ask the user to enter something. So this is something that Arthur specifically asked me to include in the lecture because you will need it in the first exercise sheet. So you can ask for input. Enter something. So now you call this function input here. And what will actually happen if you execute this, it gives you this text field. It asks you to enter something. Maybe we can enter 12. And now the number that we entered is stored in this variable s. So s now contains 12. But if we ask for the type of s, the type is actually a string. So what's stored in this variable s now, it's not the number 12, but the characters 1, 2. So it's 2 characters that make up a string. And if we want to calculate with that, we have to convert that into a number. So for example, we can convert that into an integer. So we can say int of s. What this does, it takes this text with these 2 characters, 1 and 2, and it tries to interpret this as an integer, so as a whole number. And it gives you the number 12. You can also work with other strings. So for example, you can write the words hello world. So s2 is equal to hello world. And in Python, what you have to do is if you have some text and you want it to be interpreted as a string, you have to enclose it in quotes, and preferably these single quotes. So now s2 is a string hello world, and the type of s2 is a string. One thing that's a bit confusing in Python is you don't have to use these single quotes, you can also use double quotes, so Python doesn't really care. You can also say hello world. So for Python doesn't care whether you use single quotes or double quotes for your strings, but the style guides say that it's considered a bit more beautiful if you use these single quotes. But you're free to use whatever you want. And now we have these one string hello world with single quotes and the other string hello world with double quotes, and actually they are the same string, so Python doesn't really care whether you use single or double quotes. So s2 is equal to s3 is true, so they are exactly the same string. For strings you can count the number of characters in the string, so you can use len of s2, and it gives you 12. So this is 1, 2, 3, 4, 5, 6. So the comma is a character, and the space is also a character. So it counts the number of characters overall in the string. And you can also concatenate strings. So if you have 2 strings, and you want to put one string at the end of the other string, it's very simple. You can say s plus how are you, for example. Oh, now s is 12. Oh, I didn't mean this. I meant this. Hello world, how are you? So now what Python did is took this string in the variable s2, which says hello world, and then it just attached this other string, comma, space, how are you, to it. So it just concatenated these 2 strings. You can also access the individual characters in the string. And if you want to do that, you have to use these brackets. So if you use brackets, then inside the brackets you can say which character you want. And Python, like C and many other programming languages, starts counting at 0. So if you want to have the first character, you have to say that you want the 0th character. And this should hopefully be an H. Yeah. So you can access the 0th character, which will be this one. So you get this H. And then you can also ask for the next character. So the character at position 1 is an A, or it's an E. And you can also ask for the last character. So you can, if you give negative numbers, it starts to count from the end. So as at the position -1 should be this question mark. No, it's S2. Let's see. Oh, here. S2 is this string. So the last character is the D here. So if you say S2 at the position -1, it actually gives you this D, which is the last character in the string. with this you can access individual characters, but maybe you want to access the first 1, 2, 3, 4, 5. You want to access the first 5 characters. So the character position 0, 1, 2, 3, 4. And it would be very inconvenient to do it like this. So you can do something like this. You can tell Python, give me all the characters starting at character at the position 0 and excluding the character at position 5. So the last one is excluded. And this gives you exactly hello. So this slices this part, this part out of the string. And this is also called slicing. So it slices some part out of your string. You can also take the characters 5 to 10. I hope. So you can slice arbitrary parts out of your string if you want. What you cannot do, however, is you cannot, by this, change the first character. So you cannot do something like S2 at the position 1. That was this E of hello. This should be an A. So you cannot write, you can only read from the string. You cannot write into the string. If you do this, it gives you an error. Python gives you an error. And it tells you string object does not support item assignment. And how this is called that strings are immutable. So once you created a string, you cannot change it. It's immutable. It cannot be modified. So you have to create a new string if you want to do that. Then there's another possible problem that you might want to run into. And you might want to write something like, I'm fine. I'm fine. What's the problem here? Yeah. Yeah, there's this one, yeah? This one, Python thinks that the string ends here. So this doesn't work because you cannot include this apostrophe in the string because Python thinks that the string ends here. Does anybody have an idea what we can do about this? Yeah.
Well, maybe if you use the double strings instead, and then if you use the apostrophe as well.
Yeah, that's a workaround. I think that's the main reason why in Python you can use single and double, how are these called, apostrophes? Or? Quotation marks, yeah. Single and double quotation marks in Python, because if inside that string you want to use the single quotation mark, then you can still use the double quotation marks on the outside, and Python does not think that the string ends here. Another possibility, so that's okay. Another possibility is to say I, and then in front of that single quotation mark, you can put a backslash. And what this backslash actually means is it tells Python that this next single quotation mark is actually, it should be part of the string. It should not end the string. And this is called to escape that to escape this symbol. So you can also use this. So either of these possibilities is fine. Then there's another problem that you might run into, and if you have a very long string, it might go over, or you might want to have a string that goes over multiple lines. So you might want something like this. This is a long, and then you want to have something like this in the next line. What's the problem here? Why doesn't this work? Yeah, so here there's this new line. It ends the entire statement. And this doesn't work because you cannot distribute this string over multiple lines. There's a workaround in Python. So this doesn't work. But there's a workaround, and this is to use triple quotation marks. And then you can include line breaks. This is a long string. Oh, and if you want to print a string, you can say print s. So if you use these triple quotation marks, your string can go over multiple lines. Another way to include these new lines in your string would be to do something like this. This is a long, and then you say you do something. You do \n, and \n is a code for a new line. So it gives you a new line inside this. Let's see whether this works. String. No. So \n actually says that \n is not an n, but it's a new line. Maybe we can add a comment here. \n means new line. Okay. You can also use \/ in other occasions. For example, if you work on Windows, you might want to access some file on your disk. So you might need a string like C. I think it's called user or users in Windows. I don't know, user. New.text or something. And what's the problem with this? Why can't you do this? Yeah? Yeah. So it says that \u, I don't know \u. It should be some special command, and \n is a new line here. So what you have to do if you want to do something like this, if you want a real \/ in your string, you have to use double \. So the first \/ means escape, and the second \/ means now I really want a \/ I don't want a new line or something. And now if you print that, you get something like this. You can also format strings. If you create strings manually, all of this is fine. But if you write a bigger program, and then often you want to compose strings out of other strings. And in order to do that, you can use this you can do it with this plus symbol. You can just concatenate all the strings with plus. But sometimes it's very inconvenient. So Python has some string formatting syntax. So if you have one string that is hello, and then you have another string that is world. And now you want to compose a string out of these, then you can do something like this. Like hi, and now, so you have a big string, and inside that string you want to add other strings. And you can do it with, here I want the first substring to go, so the string with index 0. And here I want the other string to go, the substring with the string with index 1. And then you say format. And then you just tell it what should go at position 0. At position 0 we want S1. And then you tell it what should go at position 1, S2. And now if we print that, I hope that works. Yeah. Or maybe we can add an exclamation mark here. So you can either number all the strings, but sometimes it's inconvenient to number them, but you want to give them names. And you can also do that. So you can instead do something like this. S3 is high, and now you don't want to give it the number 0, but you want to say, oh, this is a greeting. And this is the object. And then you format the string. And you say that greeting should be welcome. And object should be world, maybe. Now this object here is green, so maybe that was not a smart idea, because object is a word that's already used in Python. Maybe we call it what. I hope what is not used. So you can also use format strings like this. Then you can also search in strings. So, for example, in the string that we just created, S3, we can find the first position of the letter L, and it tells us that the first time the letter L appears in that string is at offset 9. Then we can also check whether a letter is occurring in that string, and we can ask whether the letter L is occurring in the string S3. So this is true. The letter L appears somewhere here. And we can also replace letters. So we can say S3 replace all L's by P's, for example. So now we have replaced all the L's by P's in that string. We can also split the string by, you can say split. Maybe we want to split it at, we want to split the individual worlds, so we want to split it where these space characters are. And now it gives us something where this is split by these, it's split up the individual words. Maybe we can store that. And now here we have the individual strings, but they are surrounded by these brackets. And let's check what this is. So we just ask for the type of L. And Python tells us that this is a list. So it's a list of strings. And lists are, in my opinion, lists are the most important data type in Python. So we can talk about lists. And you define lists with brackets. So you can have a list of integers, for example, with the integers 2, 5, and 8. And now you have this list of numbers. So the type of L is list. And you can basically access items in the list by their index. So you can do most of the things that we have seen for strings up here, you can also do for lists. So you can look into the list and get the item at position 0, which is a 2. It's this one. And you can also look at the list and slice it and get all items starting from the first item and excluding the third item. So the first the item at position 1 and 2. So that should be the 5 and 8. And this gives you back a new list. So this is slicing. Then you can also check for the length of the list. This is the number of elements in the list with len. So this tells us that the list L has 3 elements. And in contrast to strings, we can write into lists. So lists are mutable. So we can say that the list at the position 1, the element at index 1, should not be a 5 anymore, but it should be a string, maybe the string hello. Oh. And now we have changed the list, and the element at the position 1 is not not a 5, but it's a string hello. We can also, exactly as strings, we can concatenate lists. So we can say we take this list and we add another list, 2, 9, 11. So here we create a new list and we add it at the end of the previous list. And then the 2 lists are just concatenated. We can also say something which I find a bit funny. We can say L times 3. Does anybody have an idea what should happen if we multiply a list by 3? Yes?
Every element is multiplied by 3.
I would think that every element is multiplied by 3, but the problem is that the first element is a string hello. And a list can contain arbitrary elements, which we cannot necessarily multiply. So what happens, what Python does, it just attaches the list 3 times. So it's just a list, but 3 times, one after the other. Then we can also append elements at the end of the list with this function append. So we take the list and we append the string t. And now we have the same list and the word t got appended at the end. We can also try to sort the list. I'll sort. Oops, something happened. And it says smaller than is not supported between the instances of string and int. Does anybody have an idea why we couldn't sort the list? So sorting the list means first the smallest element, then the next bigger element, and the next bigger element, and so on. Yes?
And because you can compare strings with integers?
Yeah, I didn't know whether 2 is bigger or hello is bigger, right? So Python couldn't compare 2 to hello, so it just complains that we cannot really sort this list because we don't know whether 2 is bigger than hello or not. But if we have a list of, maybe create a new list of just numbers, 8, 3, 12, 2, or maybe 3. And then we say L2 sort. And then we also want to look into L2. Then it sorted the list. We can also reverse lists. Oops. So L2 dot reverse L2. Oops. Now what happened is I accidentally changed the mode of this cell to markdown, but I want it to be code. So now it reversed the list, so it just changed the order of the list. Now, if we take this L2 and we append another list 2 for 1 L2. Does anybody have an idea what will happen if I append this list 2 for 1 to my list L2? Excuse me? Yeah, so append means I want to take this new list and I want to put it on the end of the list L2. Maybe we can just execute this. What happened is this. Can anybody see what this means? Yes?
The last element of the list is the list.
Yeah, exactly. So the last element, so the list L2 has this element 12, then the next element is an 8, and the next element is a 3, and the next element is a 3, and the next element is a list. So the first 4 elements are integers, and the last element is a list. And this list also contains integers, and it contains the integers 2, 4, and 1. Maybe at this point it's good to explain what's actually happening inside Python. So one thing that I find very nice in Python is that in Python everything is an object. So for those of you who knows object-oriented programming? Okay, so for those of you, everything in Python is an object. So what happens is in this list, maybe we have an integer, and the integer has the number 3. So if I do this, then I create in the memory an integer with the number 3. So it has the value 3 and the type is integer. The problem is, now I have this object with the number 3, but I cannot access it, right? So after I completed the cell, there's no way to get back to this 3. And we saw previously that I could do something like this, x equals 3. And now I can go back to I can get the 3 back because I gave it the name x, right? And what happened in Python is I created a reference. The reference had the name x, and it pointed to this object 3, right? So I have a reference here. The reference is this x, and by this equal sign, I make the reference point to this object 3. I think we will use this diagram a lot during the lecture, so this is probably one of the most important diagrams in the lecture. Because now we can see what happened up there. So with this reference, we had up there, up here, maybe look at this. We look here. So we created a reference L2. And what does this reference point to? Can anybody say what's the object that this reference points to? So the reference L2, it points to a list object, right? So it points to an object of type list. And the list has 4 elements, I believe. 1, 2, 3, 4. So we create this reference L2, and the reference points to an object of type list. And the list, the individual elements of the list point to other objects, and they point to integers. So we have the object 8 somewhere. Then we have the objects 12 and 3. Oh, 3, okay. We have the object 12. And this is of type integer, and this is of type integer. And now the first element of this list points to the 8. The second element of the list points to the 3. The third element of the list points to the 12. And the last element of the list also points to the 3. So whenever you program Python and you get confused what's going on, you should draw a diagram like this, because it will help you a lot to find out what's happening. And these elements in the list, they have the index. So this is element at index 0, this is element at index 1, and this is element at index 2, and this is the element at index 3. Okay, now what we did is we appended this list. So we sorted it, we reversed it, let me ignore that. And we appended this new list here. And what happened at this position is first we created a new list, right? Here inside this bracket, we create a new list in memory. So there's a new list appearing here. A new object of type list with 3 elements. And they are pointing to the 2, 4, and 1. 2, 4, and 1. And all of these objects are of type int. And I think the element at the position 0 was the 2, at position 1 was the 4, and at the last position it was 1. And then we did this append. Here we said L2 append this new list. Probably I should fix the order, because before we So the first thing we did is we sorted the list and we reversed the list, and afterwards the first element pointed to the 12, and then the 8, and then the 3 and the 3. This was after we sorted the list and we reversed it. Then we called append, and then we made the list bigger. We added a new element. And what was this element? Where does this, here at position 4, where does this element point to? Can anybody? Yes? To this list, right? Okay. So at this point in the code here, what's actually going on inside the computer is this. Right. And sometimes you can be confused what is pointing to what and so on. So I really recommend you, whenever you get some strange bugs with lists and you don't know what's going on, to draw a diagram like this to really understand what's really represented inside the computer. Yes?
If you change the third element of L2 is 3, and we have the second and the third points to the object 3, and if we change the second, for example, let's say 7, so then the third will also change, or?
Let's do that. That's right. It's a very good idea. So I think we look at the list L2. This is our list L2 that's here. Now the question was, what happens if I take the element at index 2, which is this 3, and I set that to 7. Okay, everybody should think about what's happening. So first we get a new object 7. So we have a new object of type int. which is the 7. Now, we said that the element L2, which is this list, at index 2, it should point to the 7. Let's do that. So the element at index 2 should point now to the 7. Does this change what the element at index 3 points to? Yes?
Like, that still points to this thing, correct?
Yeah, so the element at index 3 still points to the number 3. It didn't get changed at all. And this is exactly, your question is exactly why I recommend you to draw these diagrams. Because when you draw such a diagram, it's much easier for you to understand what's going on. Yes?
If you have not tree, if you have a variable instead of tree, we have some variable.
Yeah, so the 3 is an integer, and integers are immutable. You cannot change the 3. You cannot change the object 3. But what you can do, I hope you don't get confused, and we might have a minute left. One thing that we can do, you can play around with this, so you can do strange things. For example, this object, this reference, you can make it point to other, so maybe we can make this point to the 7. Let's see how we can do that. So we want to take the list L2, we want to take the last element of this list, which is a list, and we want to make the element at index 1, 0, 1, 2, point to the 7. So we can take L2 at index 4. This is a list, and I access that list. I want to have the element at index 1, and I want to set this equal to 7. Okay. And maybe x is pointing to the number 3. So x is still pointing to this number 3, right? So maybe, I think what you wanted to ask is, what if I make this element, for example, point to the x, right? So actually you cannot make it point to the x, you can only make it point to the thing that x is pointing to. So what you can do is you can make this thing not point to the 8, but point to the thing that x is pointing to. And you would do it like this. L2 at the index, what did I say? L2 at the index 1, right? Should be equal to x. So point to the thing that x is pointing to. And now you get this situation that it's now at the blackboard. I think this list stuff, assigning stuff in lists, is one of the most confusing things in Python, but also one of the most useful things in Python. And I always recommend you to draw a diagram like this, and I think we will spend much more time next lecture on doing some list logic and see how we can manipulate lists and what's going on there. Okay, thank you. Have fun with the exercises and see you next week. Also, what I coded here will be in the e-learning this afternoon or tomorrow.